By connecting to your code repository, Accurix generates a topology across your full stack to reveal risks so that you can harden your architecture. It also scans code for violations against compliance and security standards to enforce best practices. In addition, Accurix develops threat models using vulnerability feeds, IAM privileges, and other data to predict potential breach paths. Learn how easy it is to get started with Accurix at securityweekly.com/Accurix. Signal Sciences secures the most important web applications, APIs, and microservices of the world's leading companies, protecting over 7,500 applications and 150 billion production requests per week. Signal Sciences Next-Gen WAF and RASP help companies increase security and maintain site reliability without sacrificing velocity, all at the lowest total cost of ownership. Signal Sciences patented technology protects any application against any attack with integrations into any DevOps toolchain. Signal Sciences, demand more from your WAF. Learn more at securityweekly.com/Signal Sciences. With 84% of cyber attacks targeting the application layer, securing your software is more challenging than ever. Synopsys enables DevSecOps with a portfolio of industry-leading tools including Coverity, Black Duck, and Seeker to help you build secure, high-quality software faster. Synopsys is the leader in application security testing. Visit securityweekly.com/Synopsys to learn more.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by Matt Alderman and John Kinsella. Join the Security Weekly mailing list and receive your invite to our community Discord server by visiting securityweekly.com/subscribe and clicking the button to join the list. Layer 8 is going virtual. The conference will still be held on Saturday, June 6th. Security Weekly listeners save $20 on their ticket by visiting layer8conference.com and using the promo code SecurityWeekly before selecting your ticket type. Please consider supporting Layer 8 or one of their partner organizations when purchasing your ticket. Some of the Security Weekly team will be in our own channel on the Layer 8 Discord server, answering questions and possibly doing some contests. Tim Mackey is a principal security strategist within the Synopsys Cybersecurity Research Center. He joined Synopsys as part of the Black Duck software acquisition, where he worked to bring integrated security scanning technology to Red Hat OpenShift and the Kubernetes container orchestration platforms. Tim delivers talks globally at well-known events such as RSA, Black Hat, KubeCon, DevSecCon, and Red Hat Summit. Tim is also an O'Reilly Media published author and has been covered in publications around the globe, including USA Today, Fortune, NBC News, CNN, and Dark Reading. Hello, Tim, and thank you for coming to our part of the globe here on ASW.
That's definitely one of those bios where you have to take a breath 4 or 5 times through.
Well, now they're all virtual, so you don't get any of the physical stuff anymore. You just get to do it all from home.
And swagless at that.
Yeah.
Yeah, we'll all get virtual badges to put on our LinkedIn profiles or something.
You know what? There's probably an industry right there.
There probably is. And speaking of industries, you have come here to tell us about open source security and risk analysis within many industries. I think it won't be a surprise that a lot of organizations are using open source software within their build systems, within their architectures. But you've been looking at this for at least 5 years. So what are some interesting things that the latest report has shown us about security and open source software?
So as you mentioned, we're 5 years into producing a report annually. This report is basically looking at the code that's one aspect of the Black Duck business within Synopsys. So that business is all about doing technical due diligence during some form of M&A type transaction. What that means for us, and what's really important, is that we're effectively looking not at survey data, but at the actual composition of real applications that are the bread and butter of a company that's in the process of getting bought. And how that software is actually composed is increasingly open source rooted, foundational, and the net result is that by being able to take a look at these types of transactions, we are able to understand what the real software powering our world is, as opposed to having an implicit bias that might be, well, we're a fan of open source, we're not a fan of open source, we're in this particular industry, or we're in a different industry. And effectively, at this point, we can very confidently say, number one, open source won the war. And number two, to the degree that it powers a lot of the innovation that we see today, with somewhere close to 90-something% of the code in any given thing having roots in open source.
Yeah, I think it's interesting. We've known these trends instinctively, right? We talk about them a lot. What I like about this report is this is hardcore code, right? This is, to your point, it's not survey data. I mean, we know it from the surveys. This is what's in code bases. And so this is validating what we instinctively know with really hard evidence.
Exactly. And last year, we were 1,253 separate code bases that we were taking a look at across, for practical purposes, the entire spectrum of software out there. And the big thing that jumps out at us every single year that we do this is that open source usage is continually an uptrend. At some point, it has to plateau. We're at 90-something% now. I can't see it going much beyond that. Maybe 95% is kind of the plateau, because after all, you do have to have some form of uniqueness and proprietary custom code in there to make your thing different than somebody else's thing. But it's the solid foundation that everything's being built on today.
And it's a good foundation too.
Yeah, I was going to say that means we're only writing 5% of our own code.
Actually, it's even worse than that. So I saw a survey year and a half ago that the CNCF had put out. And they looked at not the code in the application, but the entire stack. And they had, for their vendor ecosystem app, something like 0.5% of the code was proprietary. When you threw in stuff like it was written in Node, so that entire framework coming in and all of the sundry pieces of that, throw in Linux, throw in Docker or OCI, and throw in Kubernetes, that entire stack had an immense impact on the actual hunk of code that is actually powering that one little application. That application wasn't insignificant. It was 40,000 lines of code.
Yeah, I thought even the top 5 libraries that were in the report looked to be all JavaScript and CSS, which and all front end for that. So it was kind of interesting to see where everybody's like, "Yep, we have to build a web application. Here's the front end for it." One of my curiosities too is, how much, maybe this is more of just an open rhetorical question, is how much of that open source gets used on the back-end frameworks and the back-end architectures too, versus, here just like the code, the cloud components that, a lot of cloud native applications are putting together. And you mentioned like the CNCF. So I let me throw that just out as kind of a rhetorical question, because I did actually want to come back and say, kind of emphasize a point you made. This isn't about the question of, is open source secure or not? That's an old, boring question that has been addressed. And what you highlighted here, what this report highlighted, is that regardless of open source or not, nobody's good at patching still. And I think you even found like at least 4-year-old vulnerabilities, or 4-year-old versions being out there. So it looks like there's some fundamental, or call it foundational, to use the word of the day, problems that organizations are struggling with.
Yeah, I think really what it boils down to, and you hit the nail on the head, that no matter what industry we're in, no matter what type of software we're deploying, the act of patching is something that we still have not figured out how to do properly. If I kind of take a look at what people think of as an application, to kind of answer the rhetorical question, if I go and decide that I'm going to make a shiny new IoT thing, well, that shiny new IoT thing needs to be configured, and that's probably going to come from a smartphone app. That smartphone app is probably going to need to bring in data from someplace. Well, that's probably the cloud. That cloud is probably going to have a bunch of APIs that are going to be exercised, as well as a front-end web presence that might actually just be a responsive web app within that mobile app that was doing the configuration. So this is dedicated configuration component, but all of the reports and trends and so forth, all of the data feeds that you might be getting out of that IoT device end up being effectively some form of web framework, like say a Node.js. That's where we start to see the complexity of the situation come in. And when we start to peel back the onion just a little bit more down into the patch side of the equation, what the report really hammers home is that we, as an industry, have a bias towards understanding how to patch commercial software, but a huge blind spot for how the realities of managing any amount of open source, community created, community driven software solutions might be. And that 4 years that you mentioned, that's the tip of the iceberg. We were very, very, very happy this year to not see any evidence in the code that we audited for Heartbleed. This is the first year that happened.
Wow. We're what, 4 years out almost?
Yep.
Yeah. Oh, yeah. Just going to shake my head sadly at that one.
And
But
I'll go with the same thing with struts. This was the first year that we didn't see the CVE that was the bane of Equifax's existence for a while.
Yeah, so I think that really drives home, my question, the other sort of hidden under my question is, an organization reads this report, hopefully by no means are they taking home the message that open source, we're using open source, therefore we're going to have a lot of vulnerabilities. It's really much more the patching. I guess, are there other things that you've seen, trends within the organizations or ways that you'd recommend, organizations reading this report? What might be a takeaway, and or something additional that they should do thinking about what you found here?
So one of the big things that we definitely encourage people to do is to look at all of the avenues that open source componentry can go into their organization. And it's not just, hey, I downloaded something from GitHub, or I've got a tarred up piece of something that I can go and get from a distro. Open source is everywhere. So that means it's also in the commercial software that's coming in. It's in the firmware that's powering whatever devices might be in an organization. It's in the firmware that's powering all of the lovely IoT devices we take from home. It's in the mobile applications. It's everywhere, which means that if you don't have a management practice in place or process in place to go and recognize that each of those different avenues requires a slightly different take on patch management and version management and end-of-life statements, then you're going to be blind to something. And one of the mechanics that we see is that if a developer goes and downloads, say, a version of a component, puts it into some form of golden master repository, and then it works, and that developer didn't have a process to go and make certain that that was kept up to date, the net result is it becomes old and crusty quicker than you would expect. And then the patch management becomes a huge, huge deal, because not only are you patching for whatever thing that you thought you should patch, but you're bringing all of the functional changes that were part of the change set from whenever they downloaded to whenever that patch was applied. And that is a really big destabilizing event for a lot of organizations.
That was interesting, because one of the things that also stood out is, like, 'cause you're starting to talk about a lot of threat models here too, and how much, and the report does go into exploitability, your exploits are available or fixes are available or not available. So I think these are good threads to pull on when we're threat modeling. How much should I be concerned about or prioritizing fixes? And you just highlighted there too that there are some risks of open source, in the sense of, here is a as you're describing, here's a library, here's a component, the developer pulled down, put it into the golden master, but now the project itself is orphaned. No one's maintaining it. So even if there is a vulnerability reported for it, who's going to produce the patch for it, or where do you get the patch from? And I think another type of vulnerability that I would call out, or a threat to consider, is to sort of, I'll call it a reputation laundering, in the sense of, here is a popular open source project, or here's a popular mobile SDK, and perhaps it's just one developer working on it, not being paid by one of the large software development companies out there, gets tired of having to support it essentially for free. Someone comes in, says, hey, I'll pay you this amount of money, make me the source maintainer. And then that person takes that reputation, that good reputation of that component, starts to insert adware, or starts to slowly insert a crypto miner, so some malware over time. So these are some interesting attacks that we've seen precedent for, in fact.
And I'd throw another one in there, and this is one that really gets to the complexity of open source management. Let's say that you take that popular component and it's got its handful, 1, 2, 3 core maintainers, and then someone who has a greater propensity for commit activity goes and forks that code. And suddenly there's this massive flurry of activity that, to someone who doesn't know who the real upstream origin should be, starts to base their code off of. And if that person who's giving that flurry of activity happens to be a malicious individual, now there's ambiguity as to what the quote official version is. And that ambiguity is something that can enable a whole class of supply chain attacks when you don't necessarily know where you're getting your code from. And so that's why, from our perspective, we want to have everyone understand where they're getting their code from, because that's where the patch is going to need to come from. And that's what you should be reviewing, as opposed to saying, well, I'm going to verify OpenSSL, because there are literally thousands of forks of OpenSSL out there.
Yeah, speaking of supply chain, so you already mentioned one of the easy problems in security called patch management. I suppose the other easy problem is supply chain. And to be clear, I'd say that very heavily sarcastically. The report calls out bill of materials. And so here's something that's trying to address that supply chain problem that by no means is easy. What are some challenges that you've seen related to open source software and having a really inaccurate bill of materials?
So there are a couple of complexities. The origin is definitely one of them. The other challenge is once you get something that's packaged up. So let's just say that you've got an RPM of something. That RPM probably contains a bunch of sub packages as well. And unless you're actually willing to recurse down to where things came from, you're in essence saying, I'm going to trust the source of that RPM and the people who compiled it to not have done anything bad. And importantly, also have kept everything up to date. That's where things start to fall off pretty quickly, because when we go and take off our research hat and we go and we put on our commercial hat, one of the things that we see quite consistently is someone saying, oh, well, where did this package come from? I don't see that in my bill of materials. Well, that's your top level bill of materials that you might have gotten from, say, a POM file or from a manifest. But it pulled in a whole bunch of other stuff. And if you didn't know where that came from, that's part of the overall supply chain. You just happen to be dealing with the first step or the first stage in that supply chain, not the entirety of what's in there.
Right. I think the challenge, Tim, with open source is that we're embedding so many other libraries and binaries in other open source projects that this recursiveness and the lack of understanding of all these, recursive relationships has an impact from a security and an attack surface perspective, but we don't necessarily see it because we just look at the top level library, not realizing all those other dependencies.
Correct. And that's...
Sorry. Real quick, Tim, it'd be interesting to see a breakdown between which, intentional includes have intentional dependencies have a vulnerability versus the down the path.
Yeah, so we don't break it down that far at this point. It is actually a project that I'm trying to sponsor internally to get an understanding of more what forks you end up with the greatest version, let's call it mismatch. So if we keep life incredibly simple and say that we've got Debian versus Fedora, we know that those are both well-maintained distros. They're well-maintained solutions that may or may not always have exactly the same code at the same point. Once we get away from a well-maintained distro, then it becomes an awareness of fork management and package management within those forks. And what I can say is that our team has regularly gone and done one level down to try and identify what the actual impact of a specific CVE or a specific suite of CVEs, with the net result that what was contained within the CVE for things like what the version spray might be or what the actual impact is didn't necessarily capture everything that it should have or as completely as it should have. And so when we run across those scenarios, we do try and work with the issuer to get those things amended. But it's, again, a function of the whole community and who's aware of exactly what phase of that supply chain.
That's interesting. I'm curious too, maybe going back a little bit to especially like IoT space, and this is getting into some more technical details, but packages that are doing static linking of pulling in their libraries and dependencies. Once you get that static linking, unless the package provider is really good about that bill of materials, the system that it's running on might have one version of OpenSSL, but might have statically linked its own version of OpenSSL that has, we'll pick on Heartbleed, that is actually vulnerable to Heartbleed, or just has some other bad flaw in it that exposes it to DOS or something else that just isn't a good thing for a small IoT device. So I'm kind of curious, let's see how I phrase the question, does where you've seen the open source components live make a difference in either the patch management or kind of how many vulnerabilities you've seen? And when I say where, sort of front end versus back end architectures, IoT, or maybe even just in industry slices?
So if I take a kind of an industry slice, the patch management, the open source governance tends to be weakest in areas where there's the greatest innovation happening. So where time to market is a true pressure point versus organizations or industries where they're either subject to a lot of heavy regulation, or they happen to be a little bit more mature, so they're not under the effective land grab, if you will, that we see out of, say, an IoT space. Another good example would be the application inside of a container versus the base image itself. So the base image may have one version of it, OpenSSL, but the application may be compiled with something entirely different. And if there's a mechanism by which you can attach to one of those running containers, now you potentially could exploit something that was effectively blinded off from the application's development team, because whoever was doing the hardening of the base image wasn't communicating as well as they could with the requirements that the application development team were going to put on that particular base image.
Right. Multi-stage builds to get out all those dependencies you're not using.
Yeah, cherry picking files, all
done.
that kind of fun stuff. Yeah.
Well, there's also the end of the report makes some great recommendations, and by no means is it meant to, none of this is predicated on any fear or FUD associated with open source security. Hopefully you just want to reiterate that point.
Oh yes, definitely.
Because there's also a recommendation at the end to engage with the community. So I'm kind of curious, what have you seen, or let's explore that a little bit. What's that call to action, so to speak, to helping open source?
So there's a couple of tiers of community that we look at. There are the big marquee ones, so engaging with Kubernetes or Docker or Linux. That engagement can happen in many different ways, but it really boils down to know where you're getting your code from. The idea being that you want to at least have some type of awareness that there's a change that's going to happen. That change might be a new default setting for a file system, a new default setting for configuration. But knowing that that change is happening, that's a cool deal. Next tranche down from that is really where you start to see the big up and coming technology. So if we were to look at Kubernetes from, say, 4 years ago, for early adopter organizations, that was truly the Wild West. Everything was effectively in flux. There was no guarantee that 3 months from now, the way that, say, a pod or a service or before jobs existed, any of these things would behave the same way in a future version was far from guaranteed. If you were building an application that was going to interface with Kubernetes, then you needed to be part of that community so that you could at least be aware of the changes that were going to be potentially breaking acts, but ideally also steer it towards things that are going to be valuable to your particular use case. Because at that point, it's kind of a mush of code, and the net result is, if you're not actually molding it in the direction that's going to be productive, you could actually be boxed out and effectively get pinned to some obsoleted or unsupported fork or origin point or what have you. The next tranche down from that is the stuff that is truly foundational. And that ends up being under two pillars. The first being things like OpenSSL, where there's a reasonable amount of activity going on, but there's not a whole lot of, let's call it new DNA coming in. That could also be things like NTP and all of the various things that the Linux Foundation with their core infrastructure initiative is really looking to try and raise the awareness of. And then there's all of the tooling. And so the tooling starts to become a question of who is the one who's actually going to own that, who's the one who should be aware of what's going on. That's the area that gets the least amount of focus. And so from our perspective, if you take those top tier things, those top 3 items, and go and start engaging within those communities, then you're now in a position where you can actually both improve the situation within your organization in terms of awareness of activities and trying to eliminate the potential for something to go end of life, things of that nature. But you also end up with dev teams and ops teams who feel a much greater connection with the code that they're working with, because they're part of not only the community that's creating it, but they're also able to put their fingerprints on it within their organization.
Yeah, I think putting those fingerprints on it can be. You described a lot of good approaches for it, and they could be in depth. Sitting on an architecture committee, I imagine, steering committee, kind of like you were saying, as well as just something small about suggesting alternate or more secure defaults. We had about a month ago, we were talking to a gentleman, Brad Giesemann, just about it would be great for Kubernetes to have better defaults so everybody could benefit from it, and that kind of ties into what you were saying about the Wild West of the expectations about, is the next version bump, either major or minor, going to change things significant on me? So participating in the community is a great way to help influence and guide that, so that the actual baseline security just becomes better. It was really neat to see that recommendation in the report.
Yeah, and that baseline security really is one of the key elements, because a lot of people think, oh, well, I can't be part of an open source community because I don't code. If you're running it, if you're operating it, then you have valuable input, because you had to potentially work around, say, an insecure default. And we've seen no end of databases that are published that have insecure, lack of secure configurations. If that knowledge can be pushed back, and there's a simple little config change that could be put into a pull request, let's do it. Mm-hmm. Let's make certain that we're securing it for our environment and the environment of those who don't necessarily have the immediate skills to recognize that this is or isn't a secure configuration.
Yeah. And we should be contributing back from an open source perspective, our enhancements back to the open source community and the projects, right? I mean, part of leveraging that code is, if I make improvements to that code, let's get them back into the core code base. In a configuration could be a simple contribution back, even if you're not, providing code back into that open source project.
Exactly. And one of the things that I've had multiple discussions over the course of the last year about is whether businesses attaching themselves to a permissive license like an Apache 2 or an MIT is a good thing from a security perspective. And one of the assertions that our team has started to make is that there's a, let's call it, value that's not well appreciated within the reciprocal license world, that if you happen to have discovered a security issue and have come up with a patch, there's a greater incentive to improve the security of the underlying software from a reciprocal license than there is from the more permissive licenses out there. And so it really reinforces that anyone who's deciding that they're going to release code under a specific license needs to look at all the facets, not just how much adoption their code might get, but also what the security of the end product should be.
That's a great point.
Yeah. I wasn't sure, John, I wasn't sure if you had something you wanted to toss in there.
Probably. I forgot it already. I think we've probably made this point on here before too, is especially for this audience, we've got a bunch of, security and DevSecOps types. Contributing back to open source doesn't have to be code. I mean, it's a lot of people, they're getting better, but a lot of the open source projects are being developed by pure coders, right? They're not thinking about security. So even if you can just do preferably a pull request, but it could be a documentation like a one-pager, like here's how to deploy this securely. You'll see it on the bigger projects already exist, like on Kubernetes, where you got Google driving it. But a lot of the smaller things out there that are being used, especially the JavaScript space. I mean, I don't associate JavaScript and security really together at all, except in a bad way. So to see that 50% of these projects are using JavaScript, there's probably all sorts of help out there that you can give.
Exactly. And considering that the top, I think it was 5 CVEs from last year were associated with functionality that was all about polymorphic behavior and prototype management, that really speaks to the value of understanding the type of code that you're writing, so that you maybe by default you don't have a language that is going to accept prototyped code or untyped code, and that you explicitly have to enable it. But that's a discussion that makes sense within that community, but it would go a long way towards removing a particular class of security issues that has, at least this year, been top of list, as well as being top of list last year.
Yeah, I would be really curious to see that, one of my personal, speaking of JavaScript frameworks, fondly, is React.js, because it's one of the ways it's helped just to completely get rid of the class of cross-site scripting vulnerabilities. And in this report, there was a recommendation, if you're not on jQuery 3.0 now, because the report found that there was a lot of 1.0 and even 2.0 or 2.x and 1.x versions out there, you should figure out, you should consider that migration path. And so I guess looking ahead, I'll be really curious next year, and hopefully sooner than 4 years from now, just what that migration path is going to look like for these organizations moving on to better designed or more flexible libraries, or libraries that are actually more so addressing classes of vulnerability, so we don't see so many CVEs associated with cross-site scripting, which was a pretty recurring acronym throughout that entire report.
Yep. And I'll throw in other platforms that are going through the same version jump. So Strut's getting rid of 2.3, Python, the few others that are all looking at, well, we've made those class of errors before. We need everybody to migrate onto something that we believe is going to be far more secure, far more stable, far more scalable, and build the next class of applications.
Yeah, well, I think in the 30 minutes or so that it takes us, a developer, to listen to this particular segment, it may take them a little bit longer to migrate their code, but we'll hope at least they listen and get started on that, or take some time to read through the report. Tim, I want to say thank you for joining us.
You're quite welcome. Thank you. Thank you for having me.
This is really good, and hopefully everyone will take the time to read through that report. Has some good gems in there and some good forward-thinking things, as well as please go and embrace and join the community in whatever small or big way you see, because we've also got recommendations from Matt, Don't Give Up Roots. I want to thank him for joining us and make sure we get that in there, and thank John as well for joining us today. Thanks, everyone. We're going to see you next week on Application Security Weekly.